Hi everyone, welcome back. This is Redox Lesson 3, and we're in Part 3 of our notes, how to identify a redox reaction. How do you know? So they are going to give you, in a question, a list of reactions, and you are going to have to identify if the reaction is redox or not, okay? So one thing you can do, because we know that in redox, electrons are gained and lost, you can assign charges, and if charges are changing, then the reaction's redox, okay? So you can assign the charges, and then if there's a change, the reaction is redox. That's one way we can tell. Sometimes that can be a lot of work. So many times there are shortcuts or things to look for, like a single replacement reaction. Anytime you have a single replacement reaction, which I call the other woman, that will always be redox because you have an element by itself, and the oxidation state of any element by itself is always 0. Okay? And then you have elements and compounds here. No group 1, no group 2, no fluorine, hydrogen yes, so it's +1, chlorine is -1. Since zinc is more reactive than hydrogen, it wants to be in the compound more, and it kicks hydrogen out. So now on this side of the reaction, hydrogen's by itself, and its charge is 0. So hydrogen's charge is changing from +1 on the left to 0 on the right. And if the charge is changing, it will always be redox. That's the definition, or that's how you know a redox reaction. For the record, zinc's charge is also changing. In here, it's +2 in compounds, right? And chlorine's -1. So when you have an element by itself and then on one side, and then that same element in a compound on another side, it will always be redox. So look for single replacement reactions, look for the other woman, those are always redox. Double replacement reactions, which are the wife swappers, those are never redox, okay? So single replacement reactions are fairly easy to recognize. Have a great night, everybody. We'll see you tomorrow.